inverted conical tank. The height of the tank is fixed at 6 meters. And diameter of top is 4. So 6 meters. The diameter all the way across is 4 meters. What's happening is I've got water leaking out at a rate of 11,000 cubic centimeters per minute. Now notice, centimeters, meters, centimeters, meters. So, and then meters here. So we have to be really careful right now to convert properly. So because I want to somewhat follow what they have, I want to see if they took everything to centimeters or meters. Let's see what they did. Looks like they're going to do everything in centimeters. So we'll convert all our meters to centimeters. And that way it's somewhat consistent with what they did. You could go either way, it doesn't matter. You can go, you could take everything to, oh, right here it's centimeters. So we just need to make sure that we take all of our meters and convert to centimeters. But what I was saying is you could go the other way. You could take all centimeters to meters, but then your answer would be in meters cubed per minute. So converting, let's see here. There we go. So hold on just a second, guys. Okay. So let's just change this over. Meters. So 1 meter is 100 centimeters, so 4 meters is 400 centimeters. So this is 600 centimeters. And then the water was being pumped in, or sorry, water was leaking out. So I'm just going to put a little water's coming out at 11,000 cubic centimeters per minute. Water is also going in to this tank, but I'm not told. Okay, I don't know how fast it's going in. And then I'm told that if water is rising, if the water level is rising at a rate of 20 centimeters per minute when the height of the water is 2 meters. So I have water in here, and what I'm being told is that when it's 2 meters high, that means when it's 200 centimeters high, it's actually water levels going up. Okay, it's rising at a rate of 20 centimeters per minute. At 20 centimeters per minute. Okay, so let's try and put a bunch of stuff together here. I'm given what I want. Okay, so I know that water is going out. Okay, I know that water is going out of this thing. That's a rate at which it's going out. And then I have water coming in. Okay, so the volume, the change in volume with respect to time is right now it's at negative 11. Sorry, negative 11,000 cubic centimeters per minute. That's what's going out, dV, dV dt. Okay, now what I want, and I should say out, the volume going out, and this one's the volume going in. I want to know the volume going in. I want to know it at exactly the moment where the water level is 200 centimeters high. So why don't I call that H for height? I want to know that when H is 200. And what else do I know? Also at that instant in time, dH dt, the height is going up at 20 centimeters per minute. Okay, but this is all stuff that I'm given when I want it. So let's try and talk about the total, the volume, what's happening with the volume of this thing. The volume is the volume in plus the volume out. All right. So let's try and come up with an equation for the volume of this water. The volume of the water, right? Since this is, we're talking about this piece in here. The volume of the water, since the cone by formula is 1/3 pi r squared h, where h is the height of the cone and then r is the radius here. Now, we know h in the problem, okay? We're comfortable with that, but we don't have an r. Now, we know the radius of the entire tank is half of this diameter, so we know that this is 200, but we don't have the radius of the water when it's down here. So what I need to do is come up with like a little general picture of what's happening there. So imagine taking this whole picture, okay, and cutting that cone in half and looking at it like a cross section. Like this. You have your water level right here, and if I draw a line right down the middle, I create basically two right triangles there. This top piece right here is 200. I know that the distance, and I think what I'll do, let me get rid of this. Okay, that's just 1/2 of my picture. The distance here to here is 600. This right here is my radius, and then this right here is my height. And what I have again is a similar triangle. Now what I'm going to do is I'm going to say this long side divided by this side, 600 divided by 200 is 3, must be equal to this long side divided by this side, which is h over r, which means that 3r equals h. So what I'm going to be able to do is actually, I'll go the other way, r is 1/3 h. What I'm going to be able to do is go to my volume formula here, go volume is 1/3 pi, but r here we just said was 1/3 h squared times h. When I square 1/3, I get 1/9. I multiply times the 1/3 out here, I get 1/27. I square the h, I get h squared, and then I multiply by h again, I get h cubed. This is my volume. So now what I'd like to do is take derivative with respect to time. dv dt will be equal to constant 127 pi times the derivative of h cubed, which is 3h squared times dh dt. Now, I actually know that dh dt at the moment in time that we're talking about was given at 20. I know h at the moment in time was 200. And the thing I need to figure out here is how to deal with this. Now, remember, we already had water leaking out of this thing. So coming back up to this formula, if I were to take the derivative there, I would have dv dt on the left side equals, now this is just two terms, you just differentiate each one term by term, so dv in dt plus dv out dt. So this basically what I'm saying is that this is really just these two. So I'm going to plug that in here. This is dv in dt plus dv out dt must equal whatever all this is on this side. So we have 127 pi times 3 times h was 200 squared times dh dt was 20. Let me break out the calculator and do that real quick. I get pi. Okay. 20 times 200 squared times. All right. So remember dV in, dV out. dV in, dV out. So this was dV in dt should equal plus. Now remember, dV out was negative 11,000 equals this side, which is a really big number, 2,400,000, 2,400,000 pi, and then minus 11,000, or no, add 11,000 to both sides. So 2,400,000 pi plus 11,000 is the rate at which volume is going in. Okay, so let's see what they come up with here. I already did this. Okay, something is up with my calculation. I have this. See, they're calling it C, but this is my V in, V out, and then pi over 9, let me see. This is pi over 9, 200 squared times 20. How did I get such a huge number? And go back and look at that. Oh, no. I just wrote it down wrong. It's right there in my calculator. I don't know what's going on with me tonight. I just wrote it down. It's sitting right here in my calculator. When you do all that, you get 279,253. And then you add your 11,000. $290,253. Yeah, that's it right there. Okay, so everything is correct here. I typed that in my calculator, got the right answer, and wrote down the wrong damn thing. I don't know why I did that, but this is it. Now it's also in cubic centimeters per minute because volume is measured in cubic units. Our units were centimeters, and our time is measured in minutes. I'm sorry that was so sketchy, but I'm really trying to push it to get these things out. Haven't been feeling that great today. So anyway, this is it. That should help you out with homework.